We've spent our lives gazing at the sky, convinced we understand the world above. Our ancestors filled the heavens with stories and monsters, layering meaning onto the mysterious dance of planets and stars. But what if most of what you know about space is a collection of misunderstandings and optical illusions? The cosmos is a master of deception, tricking our senses and toying with our expectations. Today we're not just exploring space, we're unlearning it. Let's start with the very light that keeps us alive. Step outside on a clear afternoon and you'd swear the sun is yellow, maybe orange at sunset, but the sun is not yellow at all. It's a sphere of pure white light. Our atmosphere acts as a cosmic prism, scattering blue light and leaving the sun looking yellow to our eyes. As the sun sets, more blue and green scatter away, deepening the color to golds and reds. From space, with no atmosphere in the way, the sun shines with unfiltered white brilliance. Astronauts aboard the International Space Station see the sun's true color. The color of our star is about perspective, not chemistry. The next time you marvel at a golden sunset, remember, it's not the sun that's changing, but the lens through which you see it. The universe hides its truths in plain sight. The phrase "the dark side of the moon" suggests a half-lit orb, one side lost to eternal night. But the moon is tidally locked, always showing us the same face, not because the far side is always dark. Every part of the moon receives sunlight during its month-long orbit. The so-called dark side is simply the far side, the hemisphere we never see from Earth. There's no side lost to perpetual night. Only the view is hidden. It wasn't until 1959, when the Soviet Luna 3 probe snapped the first photos, that we glimpsed the moon's hidden hemisphere. The real moon is a world of endless cycles, not eternal darkness. Hollywood paints the asteroid belt as a chaotic minefield, but reality is far less dramatic. If you flew through the asteroid belt, you'd likely see nothing at all. Space is mostly empty, even here. The total mass of all asteroids is less than 5% of our moon, spread over millions of kilometers. The average separation is hundreds of thousands of kilometers. Collisions are rare. Spacecraft like NASA's Pioneer and Voyager have traveled through without a scratch. The asteroid belt is more a cosmic museum than a battlefield. We imagine space as an icy void, but the reality is more nuanced. Space doesn't have a temperature like we experience on Earth. There's almost nothing there. With almost no atoms, there's nothing to transfer heat by conduction or convection. The only way to lose heat is through radiation, which is slow. If you found yourself unprotected in deep space, you wouldn't freeze instantly. It would take minutes to notice the cold. The backdrop temperature is just 2.7 degrees above absolute zero, but without matter, this cold is a lack of warmth. Astronauts experience extreme temperature swings, but only when exposed to sunlight or shadow. In the cosmic void, cold is a property of emptiness. Logic suggests Mercury, closest to the Sun, is the hottest planet, but Venus holds that title, thanks to its thick, heat-trapping clouds. Mercury has no atmosphere. By day, it's scorched. By night, it freezes. Venus's dense carbon dioxide clouds create a runaway greenhouse effect, keeping its surface hotter than Mercury's. The pressure on Venus is crushing, and rain falls as sulfuric acid. Venus is a warning. The balance of planetary atmospheres is delicate. Sometimes the universe's logic is stranger than fiction. Black holes are often imagined as cosmic vacuum cleaners, but they don't actually suck. They're extremely dense objects with strong gravity, not monsters. If our sun became a black hole of equal mass, Earth's orbit wouldn't change. Black holes have an event horizon, a point of no return. But outside that, their gravity is like any other object of similar mass. Only objects that venture too close risk being torn apart. Black holes are the ultimate endpoints of gravity, not galactic vacuum cleaners. For decades we thought nothing could escape a black hole, not even light. But in the 1970s, Stephen Hawking proposed that black holes emit a faint glow, Hawking radiation. This radiation comes from quantum effects at the event horizon, causing black holes to slowly lose mass. For stellar mass black holes, this evaporation is incredibly slow, longer than the age of the universe. But the principle remains. Black holes are not eternal. Even the darkest objects can shine, if only faintly. Space is silent is a popular science mantra, but it's not the whole story. Sound needs a medium, and in the vacuum between stars there's almost nothing. But in some regions, clouds of gas and dust can carry sound. Scientists have recorded the ethereal songs of planets and the whistling of solar wind. While you wouldn't hear an explosion in deep space, the universe is not entirely mute. It's an orchestra on a scale too vast for human ears alone. We've long assumed light travels in a straight line, but space and gravity have other plans. Einstein showed that mass warps space-time, bending the path of light, gravitational lensing. Massive objects act as cosmic magnifying glasses, bending light from distant galaxies. This reveals hidden structures, maps dark matter, and brings invisible galaxies into view. In the cosmic ballet, light is a dancer, gravity, the choreographer. Every image of a distant galaxy may be an illusion shaped by gravity. The universe doesn't care about our intuition. It follows its own, far stranger rules. When we peel back misconceptions, we find a cosmos stranger than we can imagine. Every myth we unlearn is a door to deeper understanding. The more we know, the more wondrous the universe becomes. Subscribe to Nova Narratives for more journeys into the unknown. Until next time, keep looking up and see what's really there.